Okay, hello everyone. Are we still good with the mic? Yep. I suppose I have to wait for the tech guy to start. Okay. So welcome to this session about Drupal and performance. My name is Dominique Clause. I'm a French software engineer by trade, and I've been a Drupalist for many years now. Few figures about me. I started with Drupal 6 at the time. My first contribution was in 2010. That was 13 years ago. I went to my first Drupal Dev Days in Montpellier, 2015. In 2016, I became a full-time consultant. And today is my very first talk to Drupal Dev Days. So as you can imagine, I'm very nervous, and I'll try to not say too much crap. Also notice that I'm French. That means I learned to speak the English like this in the school, you know, with the baguette and the fromage. So I'll try to do better, but if you don't understand something, just raise your hand and I'll know I'll have to repeat the last words I said. I also want to highlight that the session originally lasted for a bit longer than an hour, so I had to cut stuff. So forgive me if I don't speak about some of the stuff that are on the screen. But you can get the slides by following me on Twitter. I want to start this discussion by discovering what is performance in the eyes of various individuals involved on a typical Drupal project in a company. So we will overview that very briefly. The first guy, obviously, is the end user. Is most likely the less technical one, at least I hope for you. That means he's all about perceived performance. You know, he doesn't measure anything or benchmark or do anything like this. It's just his own personal experience with the web that he will assess if your website is fast and frictionless enough when navigating. Nonetheless, that still means that you can find some KPIs you can measure to track that. I suggest here the total round-trip time, which is the duration between the moment the user inputs his address and the moment he gets served a fully loaded website. I could have said the first contentful paint, but you get the idea. We want to minimize the number of time the user waits at a blank screen. And then when he sees something in the screen, he will want to interact with it as soon as displayed. That means the total blocking time has to be kept minimal too. All of this with no cumulative layout shifts if we can. So because we are here talking about perceived performance, we will start with smoke screen solutions, which are not actual solutions that improve performance. Let me explain. What I mean is, let's say your server has a total amount of workload to be done to serve a page. We can identify some parts of it that can be offloaded either to be done before the user asks for the page or after the user has been served with the page. So the total amount of work is the same, just the perceived performance is better, okay? So the best of all performance you can get with Drupal is not to use Drupal at all. So what I mean by this is that you want to try to magically hide your Drupal behind a CDN or a reverse proxy or something like this. And to do that, you have to get a cache hit. You must serve your page in a way that it doesn't change depending on the conditions. So you want to design your page to have a structure that never changes, and then use the various mechanisms that Drupal has to offer to serve the personalized parts. So you will use like the lazy builders and this kind of stuff. And you want to leverage also the cacheability metadata that you can attach to a render array to smartly and chirurgically, I would say, and validate your cache the least as possible. We want to have the best caching as we can here. In terms of, well, here are additional ideas you can try to improve on the perceived performance. I just want to highlight two ideas. Something that can be computed before, as an example of what I was saying. Typically, it's the image derivative. I suppose that waiting to compute an image style on demand when the user wants it serves no purpose compared to pre-render it using like when the image is uploaded, you know, with a hook. On the contrary, doing something after the page is served, an example would be lazy loading everything that's after the viewport, like the images, the iframes, and so on. So we have modules, we have tools to do that in core and so on, so leveraging it for the end user is what we want to maximize. Don't forget that every modules that are about performance usually don't deliver their best out of the box. It's not because you see a tutorial or a blog post that say activate this module that you will get everything magically, because they're made to serve the more generic purpose. So you will like to tune that to your own application, obviously. For instance, Advanced Aggregator module has a lot to offer with fine-tuning compared to just out-of-the-box enabling it. Also, you want to try to hunt, therefore, everything that will lead to a cache miss or an uncacheable page. That can be your own custom code, but also some contrib modules, like everything that's about CAPTCHA, for instance, are known to break the cache on the pages they are used on. As a side parenthesis about this, I discovered 2 or 3 weeks ago Nopcha. It's an extension on your browser that can solve various types of CAPTCHA as you browse. It uses AI to do so, and it's quite impressively well, actually. That's free also, so maybe, anyway, CAPTCHA is not very future-proof, probably. Next is the sales team, the department team. I like those guys. They will have a strong focus on performance because they want to maximize the conversion rate, and we know it's very linked to the performance of your websites. They have somehow an ambiguous work to do here because they will rely most likely on third-party libraries and tools to do their job, like analyze, track the users, and so on. But every third-party tool that you will add to your website will bring drawback in terms of performance. So you have a trade-off to do here. The drawbacks, well, are kind of obvious. The first one is that it increases the load time of your application because there's additional HTTP requests that has to be done to fetch the JavaScript, the CSS, possibly images that comes with the third party. What is fetched may not be optimal for your application. Image may be too big compared to what you need. You may have some default CSS that you will add some even more custom CSS on top of it to make it look like what you want. Also, the JavaScript may be, you may load too much JavaScript compared to the subsets of features that you will actually use. So you want to care about this. Once it's loaded, it has to be executed. So the main thread work will increase. That may impact the loading of the page. And also it may be render blocking too. So that's also an issue. Every third-party tools that you will use will bring also a single point of failure because you will now depend on the latency and availability of those third-party tools. As an extreme anecdote on this, I once worked on a website where we had to call a third party that was called Unleash before rendering a page. So we could retrieve some feature flags and A/B tests that the marketing team was playing with on the fly, to test stuff on the website. And so we depend on that to know what types of blocks and features we wanted to render on the website. So not only it's impacted performance, but the anecdote here is that one day Unleash went down, and that scenario, stupid us, has never been battle tested. So the website was broken for a few hours. Anyway, the best we can do about this is first to monitor individually every tools that we add to the website so we know their impacts on performance, and we can educate, I would say, enlighten the other guys, the teams, about the drawbacks that we introduced on the website so we can evaluate the trade-off between what we need and the impact it has. Maybe forget about this particular library that will have a too big impact compared to what it brings to your project. Once you have decided that something has to go in the project, then technically you can play with the ordering and the priority in the loading. That means playing with attributes like async, defer, where you put bits, the inclusion on the page. You might also want to try to minimize the connection time by using DNS prefetch or pre-connect, this kind of stuff. Last, also tune, again, the third party that you're using. Maybe you can cut the CSS that it will bring. Maybe you can reduce the amount of JavaScript that's used by only retrieving the features that you actually use. Other types of job in the company, maybe accessibility team, UX team, SEO teams. I know it's a complete different jobs, all of them, but they have the same, they need the same performance for their job too. They're strongly focused on performance. And they also use tools to assess it on a daily basis. You know, they will use Lighthouse, web page test, and this kind of stuff. What they will require is usually to tweak the markup, adding arias, metadatas, JSON-LD, whatever. This has usually a minimal impact on performance, but also sometimes they require features that may sound weird. As an anecdote, again, I worked on a website where the SEO team wanted a tool on the menu link edition to edit the links of headers, footers, menus, so they could enable or disable conditionally per page, per user type, what they call SEO link obfuscation, which means if they enable that on a given link, we had to transform the ahref tag, usual link, into a span with data href and a base64 encoded URL. So the purpose was to hide that a link is a link to crawlers, and we therefore rely only on JavaScripts to decode on the fly the URL and make the navigation. So I'm not discussing here if it's good or bad from SEO and accessibility point of view, of course, but you can imagine that in terms of performance, although the header and footer look the same, the markup is different on every pages, and therefore the caching cannot be as optimal as what it should be. So the solution here is, once again, discussion. You know, it's like a couple, actually, discuss and things will get better. So educate the team on the impact of the feature they're required. So here we could evaluate objectively the performance issues and try to evaluate the SEO benefits and determine whether it was worth it or not, you know. Technically speaking, those teams, what they need usually from you is browser-based performance improvements and improvements in managing the assets, most likely, images, fonts, and so on. It's a very interesting topic. There are sessions completely just about this narrow field here, this topic. There's multiple blog posts and so on. I have linked some of them, so if you get the slides, you will deep dive into the subject. I don't have time here to elaborate on this, but that's the idea. I just want to enlighten two stuff. First is the HTTP server push module. I think it's not very much used, and personally I like it, so just wanted to highlight it. I don't know if the guy that makes it is here. And the second thing is that in core we have the WebP converter for image formats. And WebP is more performance than JPEG or PNG and so on. It's not activated by default. I'm not exactly sure why. But I just want to highlight that because it's here in core and it's supported by all browsers that supports Drupal 10, then why not using WebP? Just wanted to highlight that too. We are now to the infrastructure team. They have a full overview on the infrastructure, you know, the applicative layers of your project, the tech stack, and so on. So they have also the tools to monitor the bottlenecks of the application, the network latencies, and this kind of stuff. They will most likely help you to improve on the time to first byte, because they act most likely server-sides. And with the help, you can assess the various choices that you've made for your application. So it's about just asking questions, you know, and evaluate your choice. What type of server have you used? What type of database have you used? And why did you choose that? Is your stack up to date? Do you use the latest PHP version? Do you have opcache, APCU, this kind of tools activated? Where do you store your cache? Is that in the file system? Is that in a database? Is that in Redis, MongoDB? Why have you choose that? All of these are stuff that you can assess with their help and improve. Here also, as an anecdote, my current project is I work full stack on a decoupled application that's Nuxt on the front and Drupal on the back end. It serves the APIs through GraphQL, and we have hidden the Drupal behind a CDN and implemented CDN strategies like stale while revalidates or stale if errors. We have used headers like e-tags, surrogates, and stuff to improve on performance. And I'm just mentioning it because the feedback, the return we had, the impact on performance was better than what we have expected. We took our ideas from a session that happened in Ghent 2018. It's available online. It's by Tej Tyren. I'm very sorry if I butchered the name, but you can have a look at this, and by implementing the HTTP caching tricks, I would say, that he described in his performance, we had very interesting results. I'll finish this overview by the coder. I mean by this, the guy that actually writes the code. I think that coders, we have a tendency to confuse sometimes code quality and code performance. With my colleagues, at least, I hear sometimes that a function is not performant because it's too long, or because there's too many ifs or condition in. That's the cyclomatic complexity of the function. Or that it's not split enough. That's maybe a separation of concern or patterns of this kind of stuff. It's interesting topic. It's an important topic, but that's code quality. In terms of code performance, I see two ways, I would say, to analyze the stuff. Either you have a mathematical approach. You seek for the algorithmic complexity, the memory footprint. You use big O of n square, and so on notation. Or you use a simpler approach and more basic, which is measure. You can just measure the time taken by a function and decide, therefore. So let's say, for example, you have two implementations and you can't decide which one is the best in terms of performance. You can use tools for that. The first tool I want to introduce is called PHP Bench. It's very easy to set up because it's a simple composer require on your project. As a pro tip, I would say do that in a subfolder because you don't want to pollute the composer.json of your project, neither the vendor folder. And also that way you can not include that into the repository so that you keep this tool local to your machine to test stuff. Once you have installed it, you can create classes that has methods, and using the command line, you can evaluate the method's execution against one another. So here I have a dummy example, dummy because I'm just measuring how long it will take to find a needle on an empty array using inArray, either written usual way or with a backslash in front. It's just to demonstrate the tool. So what you get is this kind of results here. Well, you will see that the second method is at least twice as performance as the first one. So if you hesitate between two implementations, that way you have a real value that has no negotiation. This one performs better. Well, here this is called a micro-optimization. The syntax with the backslash is a fully qualified name function. If you're into this kind of kink, I would suggest the EA extended IDE extension. You install it on your IDE, and it brings you tens of those, like use ++n rather than n++, this kind of thing. It's just if you're into this kink, because otherwise, I would suggest strongly you focus better on improving just one single SQL query rather than nitpicks like this. It was just, for the purpose of using PHP Bench here. I would like to emphasize also on how strong I believe into self-education in the purpose of improving your code. So we are here today to do this, so kudos to all of us. But I would suggest from time to time that you take a coffee break or a beer or whatever your drink is. 10 minutes, you scan through the issue queue of Drupal. And if a title is appealing to you, you open it and read the comments. I'm not saying contribute in any way, just saying read what the community is facing, the issues there is currently, and on the long term, this will just open your mind to new ideas, new considerations while you write your code. You know, you will just know that you have heard about something like this before, and that will bring you value over time. And it's not easy. It's easy to do, sorry, on a daily basis. Just take 5 minutes a day when you're in the subway or whatever. I also strongly believe in code review. There is a session, I think, by XGM just afterward about this, so I'll not emphasize on the subject, but I strongly believe that it's a tool that you can use. Anyway, I'll conclude this first part with a cliche. You know, all the parties, all the people we have seen so far have to work together to make the best of your project. So, to continue, we will have to get a simpler definition. I'll suggest that we said now, performance is the amount of useful work that the computer can do in a given time frame. So now when I say optimize, I'll mean either we try to do more work in the same time, or we try to do the same amount of work, but in less time. So if we want to optimize our websites, the first thing to do is to better understand how our application behaves in terms of performance. What are the bottlenecks, the weaknesses of what are the bottlenecks, sorry, and the weaknesses of our web application, the areas where a minimal amount of focus could lead to the best performance improvements. So we need tools to do that. We have seen PHP Bench already. How can we measure performance other than that? Here are other tools. I'll be in the shoes of a naive developer, I would say, that installs Drupal and wants to see how it behaves. So the first tool we're going to use is called H2Load. It's very similar to Apache Benchmark. You may be more familiar with AB, or WAK also. Those are HTTP benchmarking tool that assess the response time of a URL given some parameters. For this test, I'll do 1,000 requests with 10 concurrent clients to various Drupal versions. I have scripted that so that a Python script is responsible to do 5 times the tests over each Drupal versions. The number is chosen to be high enough to simulate an average website, but low enough that I didn't want it to put my server under too much stress. It's Drupal that I want to assess. And that's why also we're giving here an average of number of requests per second handled using that script. So all Drupal has been installed on the same server, same database, same everything, but the PHP version for technical reasons. There's no optimization whatsoever. I really just install stuff out of the box on the server and on Drupal. So that's the standard profile. I just have activated the cache. That means all options available on the /performance page, or disable also the cache. And in that case, that means everything is disabled using settings.local.php on the versions. So here is the results I've got. Let's start with Drupal 6. The average number of requests per second is totally meaningless. It depends on the settings I've used on my machine, what is doing, the hardware, the software, and so on. What is interesting is the difference between the versions. So Drupal 7, same PHP versions, behaves a bit slower here in terms of a number per request per second served. I suppose the reason is because of the code size of the project, the size of the code base. If we used PHP 8.2, then that's where I have gotten the best results in terms of performance. And here, I have this weird effect that Drupal 8 seems so slow compared to Drupal 7. I highlight that that was a naive approach because I just have installed my server out of the box. So maybe there are some tweaks that we can do. But let's suppose I have this condition here. I want to explore what's going on and what I could improve. Also, I'd just like you to notice that every subsequent version after Drupal 8 performed a bit better than the previous one. And that's also something that seems weird at first sight, because we are here trying to get the front page anonymously with a cache hit. So basically, once Drupal has bootstrapped, the request is passed to the stack middleware negotiator and to page cache. Page cache does a request to the database, fetches the cache, sees that it's there, and boom, page hit. So the same amount of work is done in Drupal 8, 9, and 10 regarding this. So what happens has to be something that happened before Drupal is bootstrapped here. So let's say, maybe you have figured it out already, but let's say I don't know. I need another tool to assess this. So the next tool is XHProf. It's a PHP extension that you can install on your server. It's supposed to be okay for production. It has a minimal impact on performance. You can use a viewer to view the results in a better way, and GraphWiz to generate graph. We have a module in the community that lets you do that by just activating a module with Drupal, but it can only evaluate something that happens in the lifetime of Drupal. And here I want to evaluate something that happens before it is bootstrapped, so I will do it manually in the codes by tweaking the index.php file. The result is this cool graph. Here we have Drupal 7 compared to Drupal 10. The first thing is Drupal 10 graph is bigger than Drupal 7. The white boxes are the functions that our code goes through. The yellow path is the critical path in terms of performance. It leads to the red box, which is the function having the biggest cumulative time, which is the time taken by the function multiplied by the number of times we use that function. In Drupal 7, my bottleneck is, I don't know if you can read from here, but that's PDO execute statement. It's called 4 times, and it's a call to the database. So my database is here, the bottleneck of serving my Drupal 7 with the cache. On Drupal 10, the equivalent is this box here. It's in white, it's also the PDO execute statement, and it's also called 4 times, and it takes the same amount of time, yet it's white, meaning something weirder happens here in my application. The weirder part is this whole big yellow tree here that leads to those 3 functions, and they are require, file exists, and file include, so all functions related to the file system. So here, I have a problem with my file system on this installation. That's where I should focus my investigation to find what happens. So first, of course, I could use an SSD rather than a hard drive, but then maybe I can optimize also something regarding the file system. We'll see that later. But coming back to this slide, that explains the difference here, because we have removed the deprecated code from the previous version on each of the subsequent one. That means there's less code to autoload by the autoloader. Sorry, I forgot to tell you the whole yellow path is the first line of index.php that was require once autoload.php. So that's where I got the problem here in this installation. That's also, I suppose, the explanation for this weird gap here, because the code size, the number of files in Drupal 8 has no common measure with Drupal 7. There's a huge amount of files. And there's no explanation in what happens after the files are loaded, serving the cache hits as compared to loading the page that could explain such a huge gap. So I'll skip the analysis without cache, unfortunately. Just I want to focus to show you this, which is a comparison with cache, without cache, just to highlight that the efficiency you can expect from the cache in Drupal 8 Plus is better than what it was in Drupal 7. That doesn't mean here I have better performance. It means it's more impactful to use the cache and to maximize my cache hits on Drupal 8 Plus than it was on Drupal 7. Just wanted to highlight that. Also, if I did not cheat by activating the cache by default on Drupal 6, it was not at the time, Drupal 6 and 7. That means if I was really naive out of the box, I would have seen something like this on this test here, because the cache is not activated by default here, while it heals from Drupal 8. Now, here with this tool, we have benchmarked what happens on the server. I'll come back to the file system issue afterwards. Just notice that it's only half of the story when you are looking at the Drupal websites, meaning that here it's just the server serving the HTML. Now the browser has also to do some work with it until we get a page. that is just to highlight that when you use a tool, it's easy to get some graphs that shows something that is weird and you don't know how to explain it and you come to false conclusion. Here is the example if I wanted to benchmark HTTP1 versus HTTP2 using that tool. Because server-side HTTP2 bring no value just to have the header compressed, I would say, why using HTTP2? I mean, it's useless, obviously, looking at this. But because the benefits stands afterwards in what the browser does with that. So we have other tools that we can use. I've chosen here GTmetrix just because it's free and just because my clients use it to determine how much they will pay me. So we have this blue line here that represents the time to first bytes. It's shorter in Drupal 7 compared to Drupal 8 here. Sorry, it's different. Yeah. So that correlates what we have seen with H2 loads. Drupal 7 serves faster in my case here, but then it takes a longer time for the browser to use what has been served and to render the websites. Ultimately, I've got a similar experience to the fully loaded time on Drupal 7, 9, and 10, and well, I got lucky with Drupal 8. Remember that here we are not doing average results, it's just one try with GTmetrix, so maybe I've got lucky with Drupal 8. But the tendency is that although I had trouble with my server, the overall process seems as good as it was in Drupal 7. That means if I improve this file system stuff, I could get better results. Also, we have said that optimizing is about doing more work in same time, or same work in less time. And here we are doing more work in the same time because Drupal 10 has so much more to offer compared to Drupal 7. Actually, if I wanted to test the equivalence of out-of-the-box Drupal 10, I think I would have to enable all of those modules. I try to be as good as possible at looking at the modules. There's nothing about what is in Drupal core but not activated by default, so you will not find translations, REST API, and this kind of things. It's just what was out of the box of Drupal 10. And by using it and still having my file system issue, the performance of Drupal 7 drops by half as compared to Drupal 10, as compared to what it was before, sorry. And I will not come to a firm conclusion here, but I think it shows that since Drupal 8 and the change in the paradigm, we support better adding functionality in our system. What I mean by this is that we're not doing websites out of the box. We're adding feature in it. We're using custom code and so on. And for the same feature that was added to a Drupal 7 and to a Drupal 10, I would say the performance impact on a Drupal 7 is bigger than on a Drupal 10, meaning you can achieve more with Drupal 10. And in that regard, doing more work in the same time, I would conclude that Drupal 10 is more optimized than it was on Drupal 7 by this definition. Now, in order not to leave you with this file system issue, just using GTmetrix, that shows pretty obviously too. I have activated opcache and activated a PCU on my server. And then what I observe is that Drupal 10 now performs better than Drupal 7. And that is what I expected. I just want to highlight that you have to tweak the default settings because the file system was my issue. So on opcache, I wanted to reduce the amount of time that opcache would reevaluate the files. So that's the revalidate frequency. I also disabled revalidate pass, and the number of files to be accelerated had to be, here I have multiplied by 10 compared to the default settings. I just also want to highlight that this behavior is what I expected, just the absolute version, the absolute number is not what I expected. I expected an increase here by about 3 times, maybe, something like this. So there's probably something weird with the absolute number I've got. Maybe I forgot to divide by the number of tries or something like this. I will double check my numbers here. But the overall results is similar to what I expected. If we compare with XHprof, this was the previous version here. This is the new version with Opcache and APCU enabled, and we now see that we are no more using those file exists, file requires, and so on functions. So this file system is no more a bottleneck. And here now I fall back to having the database as a problem. And also weirdly here, request handler finish. Which probably highlights that something still happens after my request. Maybe that was the poor man's cron or something like this. I don't know exactly what happened with this box being in red here. So again, concluding by a cliche, think out of the box when it comes in performance, try to evaluate stuff. That cliche would have been highlighted by my third part on this session. Unfortunately, for a matter of time, I will have to skip it. I'll just fly through it. The idea was I wanted to take the search autocomplete module, the out-of-the-box experience. This is autocompletion rendered through Vue to render the suggestions. And because it's Vue, we cannot do this out of the box, meaning we cannot have different entity types served by Vue in the suggestions. So let's say you want to do this. I just wanted to show you a few tricks, but yeah, I will fly through. So you would have to write your custom callback. That means create a custom module. Naively, you would try to reuse the assets in the module. So use the view to render the suggestions and combine that. Then we would have explored the impact on the cache and so on. So now I have to skip that part. But basically, Vue here is just a way to have your configurations easier than doing manual requests. So you might want to just skip that part and use entity query, to do the request that corresponds to what you actually want. And then while you do this, you would notice that entity query might load some fields that you actually don't use in the suggestions. So you would do the requests manually. And while doing the request manually, you notice that you need a for loop to actually render the suggestions from what the database has served. So you will think, maybe I can pre-render the suggestions when a user or a node is updated. So you would create either a hook entity update or delegate that to a cron task, but you would pre-compute the suggestions and store that on a database. So your callback would become this, just retrieving pre-computed suggestions. And as you do this, you would notice that you are only using the database now. No more routing. You already know which callback has to be used. No more rendering. You don't need the rendering. No more anything from Drupal, actually. It's your own custom code. You don't expect a contrib module to override that. So why not skipping some part of Drupal and do a partial bootstrapping of Drupal? That means I can now have my code just in a PHP file that would partially bootstrap Drupal, create the container, I retrieve the database from the database API from the container, and execute my request. And by doing this, I have gained performance at the cost of maintainability, configurability, and so on. But for my particular project, maybe that's better because the performance has no command measure with the naive implementation using the view. So that was the third part that I have to skip on. And I'll finish with this slide. Just because it's interesting, I had this talk with a colleague of mine. When we create contrib code on our project, where do we put it? We put it on a custom module of yours. In terms of performance only, should you create one big module where you have all your contrib code, or should you split that into multiple modules? To evaluate that, I have scripted that, Python again. Create a script that generates 500 modules with just a single callback, as we've seen inside, and one big module that has everything inside together. And the difference is not enough that we can conclude anything. So regarding performance, if the same amount of code is used, splitting it has no impact on performance, I would say. So you should rather split your code. I'm not saying install any contribute module. I'm saying the same amount of code being splitted. And lastly, the last graph here is about unused module. I tried to parse Drupal.org and install the 500 most used modules on the Drupal 10. But doing a composer require, but not activate that in the interface. So it just sits there in the code base. I wanted to see what would be the impact. And actually, I thought that it would have not impact, to be fair, in the sense that on the PHP world, when your composer requires something, it gets into the autoloader. On the Drupal world, we hook into that we hack that modules that are not activated on the UI should not be autoloaded. That's what happens. It should not have impact, but it has, as you can see. Actually, over the 500 tested modules, there was no impact at having them sitting on the code, but about 20 of them that are responsible for this performance drop. The reason for that is about 20 of those modules have this in their package.json, an explicit declaration of the PSFO. And that is sufficient that Composer will actually add them into the autoloader and add the modules they depend on, and add the modules they depend on, and so on, and the PHP dependencies they depend on. So over those about 20 modules, I had this big tree of dependencies that was added to my file system. And here, this is still with the file system issue. This is still with opcache and APC disabled. So that was the reason. If I conclude by this, is just to highlight that in terms of performance, don't take things for granted, what you believe. Try it. There are the tools. It's kind of easy to use. I mean, if I can do it, you can. So yeah, try stuff in the real world. Slides will be, I'll tweet a link to the slides soon. So follow me if you want them. And thank you for attending. That was my first session today. If you have feedbacks, I'm very eager to improve myself, so let me know. And I don't know if we have time for questions. You'd say? Okay, otherwise I'm available or tonight at the social event or whenever you want, I'll answer anything you want. Thank you very much for attending.